In this video, I'll demonstrate how to construct an angle bisector. Recall, an angle bisector is a ray that divides an angle into two congruent angles. To do this with your compass, you can follow along with the notes and do this with me. You'll put the sharp point of your compass on the vertex of the angle and open up your compass to whatever's comfortable so that when you swing an arc, you pass through both sides. Whoops, didn't quite get there. Let me continue that. All right, once you get those two intersection points, you'll need to swing another set of arcs. Now, it's important to kind of visualize where the angle bisector will go. It will go in the interior of the angle. So when you swing these next two arcs, they need to intersect. So before you do that, if you want to open up your compass a little more, feel free to do that. But once you do that, keep your compass the same because you want these to be the same distance away from the vertex. So we have to have 2 points to line up. Line up your vertex and that intersecting arcs, and that will be an angle bisector. I'll demonstrate that again. So again, you just put your compass on the vertex of the angle, swing an arc that goes through both sides. In the interior of the angle, swing a set of intersecting arcs, making sure to leave your compass opening the same for those last two moves, and line up those 2 points. You're going to line up your vertex and the intersecting arc, and that'll do it. I can demonstrate again. Here we go. So again, just whatever feels comfortable here. Swing an arc so that you go through both sides. And then from those intersection points, swing a set of arcs that intersect and line that up. And there we have it. That's bisecting an angle. So let me do this in a triangle. The directions say to construct the angle bisector, ray BW in the triangle. And so a triangle has 3 angles. So when you're asked to construct an angle bisector, you need to know which angle, and you can tell by the name of it. So I'm really ignoring the rest of the triangle. I'm just focusing on this angle, and I'm just doing my angle bisector construction. There it is. You line that up with the vertex, and that'll be an angle bisector. It was a ray, so I'm going to put an arrow and tick marks. And I'll do one more. This angle B looks nice and obtuse. Show you that. So you'll notice when I go through here, I'm going through the angle B. I'm not trying to go through this opposite side. I'm trying to go through the angle here. So I kind of ignore the opposite side and I just focus on the angle. Now I'm going to purposefully do something just so I can demonstrate. Okay, right here, I went through and, whoops, and there's actually 4 intersection points. You've got this one, this one, this one, and this one. But you want the intersection where the arc that you made went through the angle. And I'm looking at angle B. So I'm not interested in where it goes through this opposite side. Okay, I want to make sure that I'm opened up more than halfway here. So if you need to adjust your compass, do it. But then leave that opening the same for these next 2 moves. And then line up your vertex of your angle and that. And I just cut that angle B in half. Okay, also there's a fact here that if a point's on an angle bisector, it's equidistant from the sides of the angle. And so that's called the angle bisector conjecture. So this is just a sketch. This is not completely accurate. But if this is an angle bisector, and if I measured from any point on the angle bisector to each side of the angle on a perpendicular path, it will be the same distance away. So if I go from here to this side on a perpendicular path and then down here to this side of the angle, it'll be the same distance away. All points on an angle bisector are equidistant to the sides of the angle.